Okay, so talking about circular functions today, we're going to refresh your memory on graphing, solving, and the applications of your circular functions. And the top three right here are basically just things that you need to make sure that you remember about your features of sine, cosine, and tangent. Sine of theta is the same thing as the sine of 180 minus theta. So basically that's letting you know that if you have theta and you do 180 minus theta, the sines will end up being the same. Cosine theta equals cosine of negative theta, they're going to be the same, and then tangent theta equals tangent of 180 plus theta. This is mostly used if you're ever, given a problem and it says that's in the second quadrant, and you know that sine is positive for both the first quadrant as well as in the second quadrant. Then you got your Pythagorean identities, which is sine squared theta plus cosine squared theta equals 1. Do realize that those can be manipulated to being sine squared theta equals 1 minus cosine squared theta, and of course cosine squared theta equals 1 minus sine squared theta. So do realize that this original identity can be adjusted and altered. Your double angle identities, which are given to you in your reference booklet. Cosine of 2 theta equals 1 minus 2 sine squared theta, which is the same thing as 2 cosine squared theta minus 1, as well as cosine squared theta minus sine squared theta. Any one of those can be used when it comes down to solving a trig equation, for example. And then sine 2 theta has just the one of 2 sine theta cosine theta. So with these examples, you want to either add them into your notes, at least this first one, and then after that, we can add you can add them as you need to. Okay, so given that sine x equals 3 over 4, and x is in between 0 and 90, we are going to find the values of cosine x, sine 2x, cosine 2x, and tangent 2x. We're going to find the exact value, so there's no calculator here. So, given that we have this, we can use our identities clearly to help us do sine 2x, cosine 2x, and tangent 2x. How do we find cosine x? How do we find cosine x? You could draw a triangle, or you use your Pythagorean identity. The one downside about doing the triangle is that if you gotta make sure that you're in the correct quadrant when you do draw your triangle, so you make sure you don't lose any negatives anywhere. But to kind of harp on the whole identity track here, since you know that sine x is 3/4, you just plug that in, square it. You're looking for cosine x, cosine theta. What's 3/4 squared? 9/16. 9/16. So when you subtract 9 over 16 from 1, you get 7 over 16. So then we take the square root. It will be plus or minus, but because you're in the first quadrant, you know it's going to be a positive square root 7 over 4. And that is our answer for this one. You guys remember doing these? All right, so sine 2x. Sine 2x is that formula of 2 sine x cosine x. And considering that we already know that sine is 3/4, and cosine we just found to be square root 7 over 4, we just multiply them all together. Okay? So what would that be?
3 square root 7 over 8.
Yeah, it's cosine. So it would technically be 6 square root 7 over 16, but since the 2 can go into both of those, it will be 3 root 7 over 8. Cosine 2x. There are 3 formulas that you can use to do this one. I would suggest what? Which one?
The last one?
No, not the last one.
Yeah, on that one.
What was it?
6, I don't know. I got confused. Where did you get the 8 from?
Because we need
Cosine squared minus sine squared?
no, not that one.
2 cosine squared and 1 minus 1.
Nope. Why would I not suggest doing those?
Because they have cosine.
And what do we have to do with those? We found cosine, didn't we?
Yeah, so that has a square root. So 1 minus 2 sine squared then.
Yeah. But not only because it has a square root, but because we found that. And what if we found it wrong? That means that every other one Granted, we have no control over this one, but we do at least have control here. Sometimes, not all the time. So, you gotta be confident in your answer. That's true, you do need to be confident in your answer, you do need to double check your work. However, why not just help yourself out and use what they already gave you just in case you got that wrong. So it is 1 minus 2 sine squared x. So when you go to plug that in, be careful, make sure you square the 3/4 first before you actually multiply by 2. So it's going to be negative 2 over 16, which is...
Or now then you can go back through and plug it back in and see if your answer's right.
Sure.
Or you can use the one.
That too.
Or you can just get this one wrong and know that if you did it the other way, you got it right.
Not necessarily. Because if you did another one wrong, you still get
How do you find tangent?
sine and cosine.
You do sine over cosine. So sine of 2x over cosine 2x, which you just found. So then that would be 3/4 divided by the square root of 7/4. Keep change flip, and it would be 3.
Oh, you said sine check, wouldn't that be 3 square root of 7 over 8?
Yeah.
Thank you. I was just looking at regular sine and cosine. My mistake. And I'm also running out of space here. Trying to squeeze 3 root 7 over 8 divided by a negative 1/8, which would be just a negative 3 root 7. That's how you use your identities to help you find different things, exact values, and things of that nature. We're going to look at another example. What you do on the whiteboard, and if you need to, add it to your notes. Okay? So here we go. If A is an obtuse angle in a triangle and sine A equals 5/13, calculate the exact value of sine 2A.
Why? There's a morning.
All right,
meeting
so-
at 10.
Since it's an obtuse triangle, okay, you are basically in the second quadrant of your circle, which means that your cosine in the second quadrant is negative. So when you sat there and did what I think you did, maybe, okay, and you plugged in, and you solved, over 13 would have had to have been negative because you were in the second quadrant. So when you multiply 2 times 5 over 13 times a negative 12 over 13, you get a negative 120 over 160. Alright? Here's the next one. Alright? You're getting your answer exactly, so again, no calculator. All of your answers should have been in what? Radians, okay? Because it said here, so they should have been in radians. And let's see, to solve this equation, you would have needed to have converted cosine squared theta into 1 minus sine squared theta. Did you do that?
No.
Why not?
We did it a different way.
And it still worked.
Find out. Alright, here we go. 2 minus 2 sine squared theta plus sine theta equals 2. Get everything on one side because this is a quadratic that needs to be factored.
Full sign out.
Factor out a sign. Don't divide by sign because you end up losing one of your solutions. When you do that, you'll have sine theta equals 0 and sine theta equals a positive 1/2. And that occurs sine is 0 at and 0. And sine is 1/2 at
5 over 6 and 5 over 6.
Wait, so when you see
4 answers.
We have 2 answers.
because you lost the other one when you divide out the sign.
Yeah, see, we did it differently than that.
No, we didn't divide out the sign. We converted the 2 on the right side to 2 sine squared plus 2 cosine squared, and then we solved from there.
So
Wait,
instead of,
you converted the 2 on the right hand side?
yeah,
So you
what?
ended up with
2 sine squared theta plus 2 cosine squared theta.
So you subtracted the 1, 2 cosine.
Yeah, so we minus the 2 cosine.
So that's where you lost the 2.
Well, no, we still got jump out. We just didn't get
Yeah,
that.
I know, the first 2. That's what I'm saying. That's what you lost.
We only get the first 2 either, so where Jones is.
I'm not saying anything.
Calm down over there.
We're gonna skip that one. We're gonna do this one next. So, alright, so with this one, yes, you would need to change that to sine 2 theta to 2 sine theta cosine theta. Again, you're bounding in between 0 and pi. Get everything to one side, because when you do that, you'll notice that both of your terms have a cosine theta in common that you can factor out. If you did the other way, where you change the cosine squared theta to 1 minus sine squared theta, you would still have a lot going on, and there wouldn't be much you can do because you have a mix of sine and cosine. One you factor out 2, doesn't matter. You have cosine theta minus sine theta, and you'll be able to apply zero product property. You can only say factors equal to 0 only. That's why it's called zero product property. So you have 2 cosine theta equals 0, and then cosine theta minus sine theta equals 0. Where's cosine equals 0?
90 degrees, pi over 2.
Power of 2. And over here, what you would need to do is you would have to add over a sine, divide by cosine, and basically what you have is 1 equals tangent theta.
Why can't you do where cosine equals sine, which is at
45 degrees, pi over 4.
Or that.
Yeah.
So whether it's here or it's here, it would have been at pi over 4. So those would have been your 2.
How did you get pi over 4?
Because that's where cosine and sine equal each other, or where tangent is 1.
Oh.
Alright, let's skip over the other examples. If we have time, we'll go back to them. I want to talk about the graphs of sine, cosine, and tangent. What do they look like? Draw on your board. What does it look like? Draw what sine, cosine look like on your whiteboard. Looks like you guys remembered sine. What I was mostly looking for was, especially for that y-axis, sine crosses at 0, 0. Where cosine crosses at 1, 0. Okay? What's the period of sine? Pi. 2 pi. It's 2 pi. What about for cosine? 2 pi. Remember, the period is the length, the x distance it takes for the graph to repeat itself, okay? So basically from this starting point to this one, it's 2 pi radians. From here to here is 2 pi as well, okay? Tangent's a little bit different. This one has asymptotes in it, and it curves up to infinity. You guys remember that? Okay? And its asymptotes occur wherever cosine was 0, which is at
Pi over 2, and then 3 pi over 4. Oh, 3 pi over 2.
okay? And what's the period of tangent? This one is pi. Because it repeats every pi intervals. Okay? To figure out what these major points were, these were the big 5. These were the main things around your unit circle: 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay? That was the easiest way to graph sine or cosine. They were all whole numbers. Okay? Don't forget about that. Now also remember that there was a general form for each one of these equations. Okay? It was, y equals a sine b parentheses x minus c plus d, and it was the same thing as cosine. Okay?
I don't remember that.
Yes, yes, you did.
We didn't write
Just
this
as
one.
before.
Yeah, you're right. The other way we wrote it was bx minus c. They were like this.
Oh, yeah. That way.
Okay? Oh, That's what versus was supposed to be. Yeah, you guys saw mostly like this.
Like that.
There's a difference between these two. What's the difference?
The B is not going to the C in the top one.
Meaning?
But it's not distributed.
So that changes your period, I think, doesn't it?
No, that's period. What is C? What was C?
Phase shift.
Your phase shift.
Oh, I
In
remember
this
those.
one, in this way, in the actual like typed form, this is the phase shift is already given. Okay? The phase shift is already given.
This is like the what's it called? The Ferris wheel is one.
Mhm.
Yeah. Now I remember these.
It's always given to you if it's like this, because whatever C is, that's how far to the left and the right you have to.
And normally
you
you have to
grab.
divide by like B to get the phase shift function.
That's what you have to do in here.
In that form.
The formula was negative C over B. That's what you had to do in this form to get what the phase shift was.
So now it just gives you it.
What did A stand for? What was it called?
Amplitude.
It was the amplitude. It is.
supposed to.
Y'all know what I'm trying to say. It's the amplitude, okay? It is what vertically stretches your graph, just like how a number in front of your parent function, whatever, y'all know what I'm trying to say. Okay? It is your amplitude. You don't want to be all particular. There's your amplitude, the vertical stretch of your graph. What did the B? What was the B? That was associated with your period. What was the formula to find your period? Because B didn't tell you what your period was, it affected your period.
Something 180.
Times B.
2 pi over B.
2 pi over B. This was the formula to find your period. So B didn't tell you what your period was, it was used to help you figure out what your period was. 2 pi over B was for sine and cosine functions. What about for tangent? What's the period for tangent?
Pi. So pi over B.
For tangent.
I know normally when we did these, it's like real life problems, always sine and then cosine. You normally never did it.
Yeah, but the ones that were tangent were the ones that like the graph. There was no application was for those. The C,
Phase shift.
your phase shift. And remember, depending on what form is given to you, that formula of negative C over B, if the B's are distributed in, and the D stood for the what? The vertical shift.
I love
These are basically your transformations for your sine and cosine functions. Again, tangent.
I didn't like the other two.
All right.
That's great.
Now the IB exam won't always use A, B, C, and D. They might try to change it up and say that you're given an equation with like P plus Q cosine X. But Q represents your what?
Associated with the period. No.
Oh,
It's
wait,
the
no.
amplitude.
It's the amplitude because it's attached to the trig function. But the P represents the what? The vertical shift is being added to your trig function. So do not let them change the letters on you. Throw it off. Whatever's attached to the cosine on the outside is your amplitude. Whatever's being added is your vertical shift. If there was a number, say instead they gave you something like Q cosine AX, what does the A represent?
Period.
The part for the period represents your B technically. Okay, so don't let them change the letters around, throw you off. Okay? To see if you know the difference of what's what. Alright. So, amplitude. If you were given a graph, how would you figure out your amplitude?
Oh, this
If
was
it's
the
like on a 3 instead of like a 1.
Okay?
the max plus the min divided by 2, or is it the max minus the min divided by 2?
Which one is it?
Minus.
Plus.
And plus.
It's going to be plus. Your vertical shift was the
Minus.
one
Max
minus min.
divided by 2.
For your period, remember your period is nothing but double the distance between your max and your min. Okay? So double the distance between your max and your min, and your phase shift. You always base it off of whatever. We'll get into applications more about that later, but these are definitely something that you need to know, especially for your homework.